A force can make an object move or turn around a central point. That turning effect is called a moment, created when a force is applied. The pivot is the point of rotation, the place where the object turns. The farther the force is from the pivot, the greater the turning effect becomes. Measure the distance carefully from the pivot to the line of force. Use the perpendicular distance, then follow the formula. Moment equals force times perpendicular distance. Force times distance. Remember the relationship. Force is measured in newtons. Distance is measured in meters. The moment is measured in newton meters. Clockwise turning, anti-clockwise turning, both can act around a pivot point. Compare the moments on either side and see if the force is balanced right. A smaller force can turn an object when the distance is increased. A larger force may be required when it acts closer to the pivot point. A spanner turns a nut with ease when the handle is long enough. A door opens more effectively when you push far from the hinge. Measure the distance carefully from the pivot to the line of force. Use the perpendicular distance, then follow the formula. Moment equals force times perpendicular distance. Force times distance. Remember the relationship. Force is measured in newtons. Distance is measured in meters. The moment is measured in newton meters. Clockwise turning, anti-clockwise turning, both can act around a pivot point. Compare the moments on either side and see if the force is balanced right. When an object is balanced and resting, it is in equilibrium. The total clockwise moments must equal the total anti-clockwise moments. Choose one pivot for your calculation, then add the moments on each side. If the clockwise and anti-clockwise totals match, the object remains balanced in place. For equilibrium around a pivot, the turning effects must balance out. Sum of clockwise moments equals sum of anti-clockwise moments throughout. Clockwise moments equal anti-clockwise moments. That is the principle to apply. Use the perpendicular distance and the answer will come into sight. So force times perpendicular distance. That is how the moment is found. Always use the shortest distance from the pivot to the forces line. A balanced beam stays level when both sides create the same effect. Different forces and different distance can still produce an equal result. Force times perpendicular distance. Force times distance. Remember the relationship. Force is measured in newtons. Distance is measured in meters. The moment is measured in newton meters. Clockwise moments, anti-clockwise moments equal when the object is balanced. Follow the law, compare each side, and the turning effects align.